When you think about clean drinking water, what comes to mind? Probably a high-tech treatment plant or a fancy filter under your sink. But what about the journey in between? We're talking about millions of kilometers of pipes hidden beneath our cities. A vast, silent network that carries water to our taps every single day. And here's the catch. In many places, a huge part of this network is made of plastic. If we're serious about getting microplastics out of our water, we can't just focus on filtration. We need to rethink the very materials that carry our water. Let's be clear, plastic pipes were a game changer for urban water systems. They're lightweight, they don't rust, they're easy to install, and they're relatively cheap. Compared to old-school metal pipes, they cut down on leaks and lasted longer. From an engineering standpoint, they solved a ton of problems, but they also created a new one. A long-term question we're only now starting to answer: what happens at the microscopic level after decades of use? Think about it. Constant changes in temperature, the pressure of the water flowing through BOO, and the chemicals used to disinfect it all slowly interact with the pipe's polymer structure. Over time, this constant stress can cause tiny particles to break off and enter our water supply. So, why not just rip out all the old plastic pipes and replace them? Well, it's one of the most difficult and expensive projects a city can possibly undertake. It means massive investment, digging up entire streets, interrupting water service for thousands of people, and years of careful planning. That's why the future of plastic-free networks isn't about a sudden, dramatic overhaul. It's about a gradual, strategic transition. To make this happen, any new material has to be just as good as, or even better than, the plastic pipes we use now. It needs to be durable, affordable, and allow water to flow efficiently. Without hitting that sweet spot, large-scale change just isn't practical. The good news is we're already seeing the next generation of pipe materials emerge. Advanced stainless steel systems, for example, offer incredibly long lifespans and are completely stable, meaning they won't break down over time. We're also seeing ductile iron pipes with special mineral linings that prevent corrosion without letting any polymers touch the water. And then there are cutting-edge ceramic-based internal coatings. These create an ultra-smooth, non-reactive surface inside the pipe that not only reduces friction, but also stops particles from being released in the first place. These innovations are turning pipes from simple, passive tubes into sophisticated, chemically stable transport systems. But it's not just about the chemistry. It's also about the biology inside the pipes. Rough pipe surfaces are like a perfect home for biofilm's slimy layers of bacteria. These biofilms can trap particles and then release them in bursts when the water flow changes. The new surface technologies we're developing are designed to be ultra-smooth, electrochemically neutral, and resistant to microbes setting up shop. This approach improves both the biological safety of our water and our ability to control microplastics. It's a whole new way of thinking. Water quality is unjust decided at the treatment plant. It's maintained and protected all the way to your tap. Another huge transformation is happening on a smaller, more local scale. Imagine this. Instead of transporting drinking water across an entire city, we produce high-quality water right where it's needed and distribute it through short, controlled networks. These micro-networks have some big advantages. The water spends less time in the pipes, which minimizes its interaction with the pipe material. It also makes it feasible to use premium inert piping that would be too expensive for a citywide grid. This represents a major shift from huge, centralized systems to smaller, distributed, high-performance supply zones. It's a perfect fit for the rise of decentralized water production, like localized purification systems. Of course, the plastic-free network of the future isn't just about new materials. It's also about being smart. We're talking about intelligent monitoring. Imagine pipes with embedded sensors that can detect particle release, pipe degradation, and any changes in water quality in real time. This would completely change how we do maintenance. Instead of waiting for a pipe to burst and then reacting, we could predict problems before they happen. The system would essentially be able to check its own health continuously, ensuring its integrity around the clock. This moves us from a reactive repair model to a proactive, predictive management system. And the vision gets even bigger. Future infrastructure will be designed with circularity in mind. This means the pipe materials themselves will be fully recyclable. The systems will be modular, making it easy to replace sections as needed, and the manufacturing process will have a low carbon footprint. Environmental engineering is no longer just about the quality of the water. It's about the entire life cycle of the infrastructure that delivers it. A plastic-free network isn't just cleaner for us. It's part of a regenerative economy where materials are reused instead of thrown away. So, the next time you turn on your faucet, remember that the story of clean drinking water doesn't end at the treatment plant. It continues through every single pipe it travels. The journey to a truly plastic-free water supply is complex, but it's a future we are actively building right now, one pipe, one network, and one city at a time. It is a future where our water is not only pure, but is delivered through a system that is intelligent, sustainable, and safe from start to finish. Thanks for watching, and if you found this interesting, don't forget to like and subscribe for more insights into the technology shaping our world.